Okay, good that I remembered that. Okay, hello everyone. Thanks for joining. My name is Hamad Zamani. I'm the Associate Director of the Center for Intelligent Information Retrieval, and it's my pleasure to be hosting Julian McAuley from University of California, San Diego. Just a little bit of information about the CIIR talk series. We started this in September 2020. In the almost in the middle of the pandemic, when there was no conference, or at least in-person conference, and we had to do something to be connected with the outside world, outside the UMass. And we realized that it's becoming pretty successful. A lot of people have been joining either our live talks or watching the talks on YouTube. So we kept doing it even after the COVID pandemic. So this is the 5th year of the CIIR talk series. And our first speaker of the academic year 24-25 is Julian McAuley. He is a professor at UC San Diego. He is working on personalized machine learning, broadly speaking. And one of the applications of these is mostly on recommender systems. So I'm sure that you know him. He has done a ton of stuff on recommender systems and have been actively publishing at conferences like KDD, CIIR, Rexis, and NLP communities, NLP conferences like ACL. So today, Julian is going to talk about knowledge-grounded conversational recommender systems. So Julian, do you want to share your screen?
I will try my best. Okay.
Okay. So without further ado, please join me in welcoming virtually Julian to UMass.
Yes, wonderful. That's the wrong button. Thank you. I didn't realize I was the first speaker, so that's quite an honor. How do we do this? Start from beginning. All right, so this is it's a fairly general audience talk, but it's one I prepared for a workshop at an information retrieval conference a few weeks back. So, for those of you who already know recommender systems very well, it'll probably be pretty easygoing, but hopefully you will learn something. I'm mostly going to talk about conversational recommender systems and what has been happening in that space over the last couple of years. Let me see if there's a way for me to see the chat. Okay, I can see the chat while I'm talking. So yeah, feel free to chime in with any questions. As I was introduced, we do lots of things broadly related to personalization. We do work in, let's see, personalized healthcare and traditional recommender system stuff, and music synthesis and personalized audio and lots of NLP problems. As you might have noticed, the way things have been going over the last couple of years, all interest has suddenly shifted into conversational agents and things like conversational recommender systems, which is basically what funds the lab these days. So that's all I've been talking about lately. So what will we talk about today? So I'll talk about a few ways we're trying to do research to improve personalized conversational recommenders, especially LLM-driven recommender systems where you have a two-way dialogue between a user and a language model. So first of all, how can we build better data sets for this task? The data sets that have previously existed for conversational recommendation have been quite limited in terms of size as well as sort of breadth of applications they look at. Second thing we want to do is to try and get more controllability out of LLM-based conversational recommender systems. So if you've ever, used ChatGPT or something and asked it to recommend you a movie, it has its own fairly strong opinions about what movies are good and what movies are bad, which may not actually agree with the opinions of the general population. So it has kind of its own built-in preferences and biases, if you like. So if you want to use that in a practical deployed setting as a conversational recommender, you'd like to have some kind of more control over what actually gets recommended. And the third thing, which maybe I'll just touch upon for a couple of minutes, is what more can we do with respect to evaluation of conversational recommender systems, which turns out to be very difficult when you have these free-form LLM agents that are talking to a user. It's really hard to tell if they have worked well. It's even hard to tell if they've recommended the thing you wanted them to recommend. So even traditional evaluations are quite tough, but there's a lot of new ways we should be looking at these problems in terms of things like beyond accuracy metrics. The goal of a recommender system might be to persuade a user to choose a certain item rather than necessarily finding an item they already like, or sort of the traditional information retrieval view of these problems. So lots of things to visit and revisit. So yeah, let's start with some history. What actually is conversational recommendation? If you go back before LLMs, it didn't usually mean conversation as such, right? Conversational recommendation more broadly referred to this paradigm of building recommender systems that tried to, I don't know, copy ideas from conversational paradigms, right? So more like sort of interactive recommenders or interactive preference elicitation rather than necessarily something involving conversation or language as such. So, the first paper I could find on this, which I think uses the word conversation, is from 20 years ago now. And it's really kind of a form of iterative query refinement. You want to figure out what kind of restaurant a user wants to go to. You have this table, which you can call it a model if you want. It has a bunch of parameters or weights or something that represent the user's affinity to certain features, like different cuisine types, different price ranges, availability of parking. And you would like to ask the user questions and get feedback from the user to iteratively determine what it is they want. And you'd like to reach a goal item in as few steps as possible. That's traditionally how you might formulate such a problem. Okay, so the user tells you they don't like a particular restaurant. Well, maybe I should downweight the attributes associated with that restaurant. And if they tell you they like something, I should upweight those attributes, right? You can imagine how this sort of thing would work. You probably wouldn't really call this conversation, right? It's not the way two humans interact, but yeah, it has that interactive component that kind of traditional recommender systems often lack, where the system is iteratively giving recommendations and the user is somehow critiquing them, maybe just giving negative feedback rather than providing, dialogue terms or anything. Yeah, slightly later, 15 years ago, people used reinforcement learning in order to learn what policies I should use to suggest options to a user, basically. So, during each turn, I could ask about a particular attribute, or I could recommend a particular item. I could recommend an item I think they will like, or I could recommend an item that will reveal the most information about unseen attributes or something like that. So I can use things like reinforcement learning to come up with a policy that will help me surface options to a user in order to figure out what they like and get to a goal item as quickly as possible. Okay. Yeah, still more recently, this sort of same question has been asked a bit more. So if I am in these iterative feedback collection scenarios, what strategies should I use? Should I recommend items at random to learn about the user? Should I do something greedy where I always recommend the item with the highest affinity? Should I recommend items that I think will teach me the most, and attributes about which I have the most uncertainty? I might learn something by recommending the users those items. You get the idea. So, what policies are actually effective for learning user preferences quickly. So that's like what really shaped early research that's broadly on this topic. I mean, I don't know how relevant some of this stuff is to today's view of conversational recommender systems, but this is what people are thinking about before LLMs in this sort of conversational recommendation space. How can we iteratively collect feedback from a user and use that to learn a policy? And this might be a little bit how you would visualize conversational recommendation. Sometimes if you're choosing a restaurant or a movie with your spouse, it's not always just free form two-way conversation. Sometimes it does kind of consist of this paradigm where one person is suggesting items and the other person is saying why they don't like them, right? So it's not necessarily so different from human conversation. It just doesn't involve natural language yet. Yeah, okay, so that's kind of half of the problem. Looking at traditional approaches, people have thought a lot about iterative recommendation and sort of personalized query refinement or something like that, where we have no language, but we have iterative personalized interactions. The other side of the coin, going back a few years, is this area of explainable recommendations where generally we don't have the iterative part, but we do have the language part. So items are being surfaced to a user and some kind of language model is then being used to explain why certain items were recommended, or not necessarily a language model, but at least recently it's been language models, right? So I might, for instance, do something which is called extractive, where I find text among product reviews that is particularly relevant to the kind of attributes you care about, and I could surface that text. That could be a form of extractive explanation. Or I could use a language model to actually write or synthesize an explanation of why a certain item is being recommended. I do not remember what paper this is from and how we did this, but there's an example. So we're retrieving items using fairly traditional recommender systems, and then we're using a language model to explain why a particular recommendation is good. So yeah, those are two halves of the problem. You have interaction, an iterative recommendation without language, and you have this emerging field of explainable recommendation, and especially explanations that use language models, usually without any interaction. So what are the limitations of this? So what were the limitations of this? One, it's not really conversation, right? When people talk about conversational agents, they probably don't mean things like this, right? They mean something that will talk to you, or they imagine somebody talking to their phone or something. So we wouldn't be able to implement most of these models by a conversational interface, right? Secondly, there has been a big issue about a lack of data sets. This is going back a couple of years now. I'll talk about some fairly recent approaches, still pre-LLMs, that tried to build data for this problem. And the third thing is that none of these things really seem to be general purpose. Like this model here, you can maybe use it to recommend Italian, French, Turkish, Chinese, German, or English restaurants. Any other kind of restaurant, forget about it. Anything other than a restaurant, impossible, right? It's a method that's completely designed around the specific attributes present in a certain data set. And that has been broadly true of most work on conversational recommendation to date as well. It's very hard to build general purpose models rather than ones that are designed around a specific product type or a vertical or whatever. Okay, so yeah, looking to recent but pre-LLM work. I mean, when did things start to become real conversation, right? So this paper from 2018, which I'm not involved with, is maybe the first that could be said to be kind of going for that goal of building recommender systems that are free form, two-party conversation. So the user can say whatever they want and the system can reply however they want. It can make a recommendation or it can just talk to the user. Okay, so still pre-LLMs, but they were using some kind of language model. I forget what it was, LSTM or something or other. But okay, they also built a nice data set to train and evaluate such models. And they did this using crowdsourcing. So crowd workers would take these two roles. They could be a recommender, so they could sort of have the role of the model, or they could be the seeker, so the person seeking a recommendation, and the recommender would have to find an item that the seeker wanted. And then, so they'd have this conversation. Eventually, they would find a nice item, and the data set would then be tagged, so we know every single item that gets recommended. So it's not just language data; it actually contains all of the items and the entities with resolved IDs and everything, all that nice stuff. And if I remember right, the way it worked is that the seeker is told what the goal item is, but they're not allowed to just tell the recommender, hey, I'm looking for aliens. They sort of have to talk about it cryptically. They sort of, maybe I'd like some sci-fi or something with horror elements or something like that. So it's a little bit more like a game of 20 questions, if you like. I think you can sort of critique this a little bit as not being quite real conversational recommendation because of the sort of synthetic way this data set is constructed. It's different from when you're trying to choose a Netflix movie with your partner, right? And neither of you really knows what you want, and possibly neither of you actually wants to watch anything. Yeah. That's the real gold standard of conversational recommendation. Whereas these synthetic settings, usually there is kind of a known item or a goal, even if the users pretend there isn't. But still, it's this is a wonderful paper. It's very ambitious. I think by 2018 standards, they're really going for real two-party conversation. They built the data set you need to build to do this, right? So we actually have real ground truth data between two people of what conversational recommendation dialogues look like. They're all annotated with goal items, so we know the objective. We can measure performance of the model. At least it seems like we should be able to. So we have a nice data set for training and evaluation. And I think everything is very principled. It's very obvious how you would train a model for this task using this data set. I can just say, well, I should learn a language model and sort of a policy that will allow me to have these conversations and get to a goal item as quickly as possible. So I actually will train language models for both parts. I'll train a language model for the recommender, and I'll train a language model for the seeker. So it's now like a two-player cooperative game, right? So I'm simultaneously training the language model for the recommender and the user. And then at inference time, I just use the model for the recommender, right? So yeah, it's very elegant. It's very obvious how you would build a model using this kind of data set if you can get a good data set out of it. Still other problems, like you're assuming the model can be trained from a relatively small data set of tens of thousands of conversations, right? Okay, but so far so good. So what are the limitations of this work? I think first, which I've said a little bit about already, is I wouldn't really call these like real conversations. The users aren't actually seeking some item. They are paid crowd workers who are playing a synthetic game. You have to think about whether that is similar to what real conversational recommendation should be. If I'm talking to my phone about a restaurant or a movie, what is my mindset? Do I have any idea about what I'm looking for, or do I need a lot of help? It could be quite different from this setting, in other words. Secondly, I think again, it's very hard to imagine how you would apply this mechanism in other settings. This is a movie-specific data set. Users are talking about movies. I don't know if you could repeat this crowdsourcing effort for a different type of product. right? This kind of works because you can pick a bunch of popular movies and everyone kind of knows about them and can reasonably talk about them. For that matter, ChatGPT can talk about them because they're very well represented in the training data. If I wanted to build this system for, I don't know, digital camera recommendation, I couldn't do it with crowd workers because it would be too high expertise. Or if I wanted to do this for like, I don't know, recommending tools at Home Depot or something, where you just have this endless item vocabulary, and you need a lot of domain knowledge to understand what should be recommended in a particular context. This wouldn't work. You couldn't get crowd workers to build your data set. So it's like, yeah, I mean, pretty much every data set is about popular movies, which is a bit limiting. Yeah, so that's about it. That's the sort of state-of-the-art pre-LLM. They built this nice data set, and lots of papers followed up on that one to sort of beat this benchmark. I mean, this became a popular benchmark that methods tried to get the best performance on, right? So I think again, it's nothing to do with our work, but from what I could find, the best method on this benchmark before LLMs ruined everything was this one called UniCRS, and you can kind of get a sense of what it looks like. These are these big models that incorporate a lot of different components, where we use a language model to understand the dialogue history. We use a knowledge graph to understand all of the attributes about the item. So we're kind of connecting this to some external database that knows about all of the movies. So we can kind of divide the problem into two subtasks, where one component is responsible for handling conversational elements, and another is responsible for handling more recommender system Z elements, right? So they use this template-based dialogue generation strategy, where it's like, oh, you want to look at a thriller movie, I'll just leave a placeholder for what the item should actually be, and then I'll use this knowledge graph model to figure out what movie should fill the placeholder. Yeah, I mean, this is kind of what a lot of work in language models and language models plus recommender systems looked like before LLMs. You were trying to fuse these external modules to get better knowledge grounding and things like that. I think it all makes a lot of sense. Let the language model be responsible for conversation, and let the recommender system be responsible for recommendation. In other words, the language model is responsible for semantics. The recommendation model is responsible for collaborative dynamics. Yeah. So that model was state of the art on Redial as of some point. Okay, so yeah, that's a history lesson. All right, so I don't know if I have the end of this history lesson, but yeah, after this point, GPT-3 came out, or 3.5, I forget whichever one was the one that worked. And you could easily beat this model just using a language model. Forget about all of your knowledge graphs and grounding and fusion and whatever. You just ask ChatGPT for a movie recommendation, and it was absolutely, undoubtedly state of the art on this benchmark, even though that actually turns out to be quite hard to measure. But we'll get into that later. Okay, so that's where we were. How can we? What still doesn't work, and how can we kind of make things better? So the first thing we've been trying to do is build better data sets for this task. Data sets that are kind of more suitable for the LLM age. So yeah, this is what Redial looked like, or still looks like. So you have 10,000 conversations like this, where you have a user and a system, and they're talking to each other, and all of the movie mentions have been resolved to specific entities and replaced by some entity IDs, so we can connect it to knowledge bases and figure out whether we got the right item, so on and so forth. Okay. So that's what our state-of-the-art data set sort of looked like. what can we do to make data sets that are kind of more natural, so that actually represent how humans would talk to, rather than these sort of synthetic two-player games. How can we make data sets much, much, much bigger, I think is the key point here. This is sort of tens of thousands. It's fine for the purpose of evaluation, but it would be hard to train a model on this data. It also has, very, very limited coverage, right? I mean, this is movies. How can we build versions of this data set that sort of span every setting? That's kind of what we'd like to do. Not to criticize this previous work too much. This data set is wonderful as kind of a gold standard. I think crowdsourced data is very nice. It's at least it's a small data set, but it is very, very clean, and it does exactly the thing we want to, even if it's sort of limited in terms of size and application domain. So we possibly like something that is crappier, but at the same time a lot bigger and has much better coverage, right? So yeah, our approach here has been nothing crazy, but we've been trying to harvest these data sets from natural conversations, mostly from Reddit so far, but there's other places you can get them too. So you take some giant data dump, like using one of these push shift Reddit data sets, find subsets of interest, which is pretty easy to do. If you care about something like movies, you look at I forget the names, r/Netflix and there's a movie recommendation one. It's called like movie recommendation or something along those lines. So there are subreddits specifically focused on people having movie recommendation oriented dialogues. Okay. So grab those subsets, do some filtering to figure out which posts are actually about recommendation-oriented conversations. Funnily enough, the way to do most of these filtering steps these days is to just ask a language model, probably a cheap language model, but say, is this a conversation about a movie recommendation? So yeah, I mean, Reddit is sort of tree structured rather than alternating dialogue, but you can think of every path through that tree as a potential conversation. So you can kind of use the tree structure of it to augment your training sets. And then you have to do all this other stuff, like identify the entity mentions, much like has been done in Redial, figure out what movies are being talked about, and then map them to some external database of movie IDs, right? Again, mostly you do this by asking a language model, but yeah, the entity resolution is kind of the tough part here. Okay, so this was our first effort to do that. We built this data set about movies on Reddit. I'm sorry, I'm using all of my time to talk about history and data sets, but hopefully that's interesting. So yeah, this was pretty easy to collect a sort of very large data set. The previous biggest data sets are on the order of 10,000 conversations. You can easily collect 600,000 movie conversations. And you can see how they're different. So Redial conversations, due to the way they're built, users sort of express their verbal preference in a quite concise and specific way. They talk about a few items that they like. On Reddit, it is very different. Like the way a user asks a question will tend to consist of them giving some extremely detailed context about themselves. This is what the user is asking for. Something I can focus on, but nothing too harsh. It can be strange and bizarre, but dreamy visuals and movement and smooth. And sometimes unnatural dialogue is what gives it a sweet sensation. That is a real user asking for a movie recommendation. It's like what they want is, on the one hand, extremely detailed, but on the other hand, it's extremely vague. Like it's not clear that there's any movie which exactly fits this query, and the user certainly doesn't know about that. It's like it's how I felt watching these movies, which maybe don't have actually much in common in terms of their manifest attributes, right? So that's typically how a Reddit conversation looks. If you look more at the statistics, the conversations are much shallower. I mean, it's a forum rather than a conversation as such. So there's 600,000 conversations, but 1.7 million dialogue turns. So it's like the average conversation depth is 3 steps or something, right? Compared to redial, where I have 10,000 conversations, but over 100,000 turns. So you have like 10-step conversations. So it's not exactly like it's better than redial. It is quite different from redial. There's a lot more information in the query, and relatively less information in the conversation. People are not expecting those conversations to necessarily be multiple turns, right? The user might provide a little bit of feedback, but for the most part, it's more like a data set of very complex, semantically rich queries that a language model needs to understand the semantics of and respond to. But anyway, it's its own thing. And we've built this for Reddit and written a paper about it, but we're doing lots of follow-up work on this, essentially to like reproduce this data extraction method for any sort of type of product you could care to think about, right? Like there's lots of different subforums on Reddit that look at different categories of item, and you can very easily reproduce this procedure. I don't think movies is necessarily even the best represented in the Reddit data set. So you can easily collect millions and millions of recommendation-oriented conversations. We just did it on movies first because Netflix was paying us to, for one, and it's a good way to compare to existing techniques as well. We can sort of compare the data set and findings of different models to redial. So yeah, what do you actually find looking at this data set? So we built this really trivial method to evaluate this, which is just based on prompted LLMs. We take some set of early turns in a conversation, and then provide it as a prompt, and the language model is responsible for providing the next turn or providing a set of recommendations associated with the next turn, right? Just to see how well a language model will understand these semantics and make recommendations. So whatever. What do we find from this? And how does it compare to existing results? All right, so first thing we find, I don't know if this was known before our paper or not, but it's not surprising either, is that, even on existing data sets, GPT-4 basically beats everything. It's within margins of error equivalent to the state-of-the-art model, which was UniCRS, the one I mentioned before. So that sort of very carefully handcrafted model using a knowledge graph and trained specifically to work well on this data set. Really mankind's best effort to build a language model that works on specifically on redial, and GPT-4 just works a little bit better. So it's confirming that is true. So yeah, first of all, we sort of confirmed that off-the-shelf language models outperform anything pre-LLMs on these tasks, which is pretty. I think if you're a PhD student who's been spending your entire PhD building conversational recommender systems, that can be a bit devastating. But anyway, we had to move on with our lives. But I think more interestingly is like how this data set we built is so different. This Reddit data set compared to redial. I think the first thing to note is this method that was trained so well to work on redial. It doesn't work at all on this different data set, which is pretty common finding throughout history of recommender systems. It's like when people focus a lot on a particular data set or benchmark, and then you collect a new data set or benchmark, suddenly the methods you believed worked really well are no longer the best. And even then, this is, it's both data sets about movies. They're both the same task. They're both roughly the same item vocabulary, but just the sort of different characteristics of the data set mean that methods believed to work well do not generalize. But yeah, I don't know, GPT-4 still does very well. I think it's not surprising at all that GPT-4 does well, because GPT-4 has been exposed to a lot of conversations on Reddit, right? It's very much within the training distribution. And we were careful to make sure we had a test set of Reddit conversations that was not part of GPT's training data and whatever. So the results are real, if you like. yeah, everything over on the right here, the four rightmost bars are other language model variants that are like smaller LLMs. Does the LLM have a fixed vocab movies to output from? No. This was a very preliminary experiment. The LLM could output anything. You could just spit out text, and then we had to determine what movies the text it spit out corresponded to. So, it generates something like this. It generates movie names as text. We just did string matching to align them with known movies, but it didn't really hallucinate. It was a finding here. Like only 5% of the names it generated could not be resolved to a known entity, right? So for this particular task, it's so in distribution that hallucination was just not really a problem. Certainly, yes, it would be in other settings. And getting to your question, like that's something you have to do better, right? Like you do need to have a fixed vocabulary of items to recommend. You can't just let the language model generate blobs of text. You need to have control over what items it generates. But that's not there yet. What else do we observe about this? Firstly, there's a lot of popularity bias and different types of bias, which is not surprising with an LLM, but in a way it's disappointing. It's like these were sort of easily solved problems for traditional recommender systems. Like you can easily control the certain characteristics of the output distribution, such as the frequency with which a certain item could be recommended. Much harder to do with the language model, right? So the left two plots, or the Reddit plot, really maybe the easiest to understand. So the x-axis shows the frequency with which certain items appear in the training data. And then the y-axis says what is the frequency with which those items are recommended. So if this were a straight line, it would say that the recommender systems are recommending items exactly in proportion to how much they show up during training. And that doesn't happen at all. So it turns out there are certain items that users really like. I don't know what this is, but users really like this item, or in this case, Avengers Infinity War on Redial. Like users like that item and recommend it a lot. The language model never recommends it. It just doesn't like it. Who knows why? And there are other items that users don't really care for, but the LLM just really likes them. It just recommends them all the time. So it's like it's just always recommending. Like it recommends The Hangover more than 6% of the time on Redial. It's like, why? Users don't mention The Hangover that much, and it just tells everyone to watch The Hangover. It's kind of weird. It's like it has its own opinions, right? Or you can just say, it has these biases. But the biases seem to be, it's not just bias from the training data somehow. It's like, yes, the Reddit data ought to be very close to the language model's biases because it's seen so much Reddit data during training, but it doesn't follow the Reddit distribution very closely either. So that's something we have to control. It's like we need to fix that, right? That's a source of bias in our recommender system. It's a source of bias we don't really expect recommender systems to have, or at least we know how to fix it in traditional recommender systems, but we don't know how to fix it in language models. Other more obvious sources of bias, like, yeah, the language model just doesn't work very well in languages that are more poorly represented in the data set or on Reddit. Again, not very surprising. I think you sort of can blame the data sets a bit for that problem. But that's a feature of language models. They work well in very high resource settings. They don't work very well in low resource settings. All right, so what can we do? That's kind of our new data sets and what they reveal about why conversational recommendation is still challenging. Like LLMs are clearly state of the art, but maybe we actually maybe we need something more like this, right? Like this made a lot of sense, where it's like, oh, I still have a traditional recommender system combined with a language model. The recommender system can then give me back a lot of that fine-grained control and debiasing and all of those things I care about. So, why can't we actually have this type of approach with an LLM, right? So, that's what we're trying to do in terms of methods. We've been exploring lots of solutions to this. Broadly speaking, they are mostly based on different types of retrieval augmented generation. The easiest type of retrieval, I mean, I don't know if you even call this RAG, but it is what I was just describing, where we're retrieving recommendations from a recommender system, would you believe, and or we're retrieving item probabilities from a recommender system, and we're using them to perturb probabilities during decoding time so that we can upweight or downweight the chance of certain items being recommended by the language model according to the belief of the recommender system. So that's kind of one way you can do, roughly speaking, retrieval augmented generation. You can also retrieve all kinds of other stuff, right? You can use traditional collaborative filtering techniques to retrieve related items to a query. You can find, here's a short list of items and their properties that are sort of relevant to the query a user wrote, and then use those to prompt the language model. You can also retrieve information from a knowledge base. If the user's talking about a movie, I can still do a lookup of that movie in a knowledge base to the extent that it might not be represented in the language model's knowledge. This is important if you want to apply this in settings like what Netflix cares about, where maybe you have new release items that the language model just hasn't seen users talking about yet. I might want to retrieve information about those items as part of a retrieval augmented framework. I can also just retrieve related training samples. I mean, this is a pretty old idea. Well, I say old, a few years back idea from retrieval augmented generation, where it's like, okay, well, I can just look for a historical dialogue or a historical conversation that is most similar to the one the user is currently having, and I can surface that to the language model as a sort of prompt for some kind of in-context learning. All right, I'm using all of these terms loosely, but those are kind of the ideas. So yeah, this first idea, which I'll talk about in a little bit of detail, but then I think I'll just stop talking because I have too much to say, is just to say, going a little bit going back to that question from earlier, how can we control the output distribution that the conversational recommender system generates? As it is, you have these items that the LLM just really likes and recommends all the time, and these items that users like but the LLM never talks about. Maybe we'd like those things to be better aligned. I mean, that would be the most obvious goal, to just say, the recommendation output should match the training distribution. That's sort of that would be a way of eliminating bias, but you could imagine other types of control. You could control it however you like. You might want to promote sponsored items, or maybe the recommender system is just a bit smarter than the language model in some ways. Maybe it knows about temporal dynamics better, or it knows about product availability, or it knows about cold start items or something. And you'd like to increase or decrease the probability of certain items. So how can you gain that kind of fine-grained control? I have 10 to 12 minutes for the rest of the talk. Well, yes, very good, thank you. There's too much talk, so I'll just stop at some point. But yeah, this is nothing crazy. I don't think the idea here is too out of this world in terms of like LLM methodology. It's just a specific application of this to recommender systems. So yeah, the idea here was to basically create movie tokens and to inject those into the language model, right? So that when it is talking about movies, it doesn't just generate a string of words, it outputs a movie token, right? And when we think the model wants to output a movie token, we can adjust the token generation probabilities during decoding using a recommender system. Yeah. So yeah, it's very similar to what this old work was doing pre-LLM days, right? Where they had a sort of a template-based generation procedure where the template is filled in by a recommender system. Now we're saying, okay, we'll do this during decoding, And when an item is going to be generated, or an item token is going to be generated by the language model, I will use the recommender system to determine what the token probability should be, rather than relying on the language model's determination of what the token probability should be. But yeah, I think this is a pretty critical piece to get these things working, is you don't want the language model to just have, to just generate English words, right? You want to somehow tokenize the item vocabulary so that there is a distinction between words and objects being generated by the language model. Going back to that question that was asked, 20 minutes ago. Sometimes the training distribution shows popularity bias, which harms cold start items where LLMs might help. Moving LLMs towards Rex's distribution might hurt capability of LLMs. Yes. I think this is a general purpose technique. What you do with it is up to you. This is a mechanism to give you control over item probabilities during decoding. Not to say you should necessarily trust the recommender system more than you should trust the language model, which, it has its own opinion. It allows you to do very simple interventions like what we did, which is just to match the training and inference distributions. But you can do any kind of inference you want, right? By any kind of intervention you want. There could be all kinds of different goals. You might have to do something special in cold start settings. But, I'm also a believer in the general principle that you don't want your language model to be responsible for everything. You want your language model to be responsible for language stuff. And you want your recommender system to be responsible for recommendation stuff. Yes? So the language model should understand semantics. The recommender system should understand collaborative dynamics. It should understand temporal dynamics. It should understand sequential dynamics. How does this relate to the thing the user did yesterday? It's pretty unreasonable to expect the LLM to handle all of that stuff. So, I would argue that, somehow we should be using a recommender system or some more traditional IR-ish thing to determine what should be recommended given a particular situation, and the language model is responsible for talking about it and understanding the semantic characteristics of what is being talked about. We did have some other interesting results here which are not in this slide deck, I'm afraid, but we talked about why language models actually do really well, and they do well because they understand semantics. They understand the red part of this dialogue. The collaborative features, like what items were consumed before, recommender systems understand those as well or better, right? And you can come up with an experiment to test this. Like you can keep the collaborative part of the query, or you can keep only the semantic part of the query. So we did these experiments where we said, what happens if you delete all movie mentions from the query? What happens if you delete everything but movie mentions from the query? And yeah, it's like language models don't understand collaborative stuff that well. They understand semantic stuff really well. So I still think there's a lot of room for recommender systems to do things that involve collaborative dynamics, or sequential dynamics, or temporal dynamics, or all that stuff that recommender systems already do. Anyway, yeah, just a teaser for other things. We're doing lots of other work about retrieval augmented generation, where we retrieve related items, or we retrieve past interactions in order to generate new prompts. I won't go into that. Or retrieval augmented generation settings where we retrieve information from knowledge bases, or settings where we retrieve related training samples, which basically means historical conversations, and use those as prompts to improve results in inference time. Yeah, last piece, which I probably won't really talk about because I got too distracted, is coming up with new ways of doing evaluation. You know, even though we've built better data sets and we've built better models, it's not really clear that we're evaluating conversational recommenders in the right way. Yeah, we're still essentially measuring whether they found a goal item eventually, right? This idea of a held out goal item is something I think is particularly not relevant to conversational recommenders. You know, it's already criticized with traditional recommenders. It's like, yeah, okay, well, these offline accuracy-based metrics are pretty limited. Users might want discovery, or they might want serendipity, or they might want diversity, or something. With conversational models, it seems even more important. Like, yeah, I really don't think that users are engaging with conversational recommenders when they have or they will in the future engage with conversational recommenders when they have a very strong idea about what they want. You know, we might like to target beyond accuracy metrics like the ability to persuade a user or to help things like discovery. You know, there's also the challenging component here that we would like to avoid doing user studies all the time. So we might like to build evaluation platforms that can operate offline, that involve simulated users. So, you know, actually using LLMs to simulate user populations, benchmark recommender systems against those simulated populations, and maybe even train recommender systems to work well on simulated user populations. I think I haven't given myself much time to talk about this. You know, mostly in an initial paper, we talked about the various ways LLM-based simulators are very different from real users and how you can maybe prompt or control them to match human users a little bit more closely. But yeah, I think I won't go into that, just in case people do have questions about other things. So yeah, to summarize, you know, conversational recommendation is kind of this interesting frontier of finally getting toward that goal you might have imagined 20 years back, where it's like, yeah, the recommender system should actually be similar to the way two people would have a recommendation dialogue with each other. LLMs have totally blown everything open. They've meant that the prior state of the art is totally obsolete, and we can use an off-the-shelf model that was never specifically trained for this task, and it works better than anything that exists. On the other hand, there's plenty to do. Like all of our work about debiasing recommender systems, we've got to do it all again in the context of large language models. There's still lots of open problems about, yeah, getting these things to work in domains that involve cold start, domains that involve high expertise or really niche content. Lots of new ways these things should be evaluated to kind of gain new light in LLM days. But okay, I'll leave it there. Sorry, I only covered about half of my talk, but that's how it usually goes. Thanks, everyone.
Thank you so much for the interesting talk. I assume you can hear me, right? Okay.
Yeah.
So we have about 5 minutes for questions. Any questions from the audience? Or I think remote participants can also raise their hands. But any questions from here?
Hello, great talk. Thank you. It's a great essay. So my question is that to solve the misalignment between the LLM and the popular comments, so could we try to fine tune those language model? There are some open source options, and you can use parameter efficient fine tuning. Is that a good way to solve this kind of problem?
That is a very reasonable thing to do. For one reason or another, I don't think we ever tried to fine tune a language model on one of these data sets. I mean, yeah, like these are data sets the language model is already exposed to. It's like the ChatGPT has seen Reddit movies. It's not like it's an out of distribution data set you need to, it's not like looking at clinical notes or something. It's like, yes, you could fine tune it, though it's not really an out of distribution data set. I think it's a reasonable approach, but I guess I do have an opinion that it's still maybe not the right approach. Like even if you fine tune to Reddit, it's like, well, okay, all I'm going to do then is pick up biases that are specific to Reddit. It's like I'm still getting all of my biases specific to that data set. And I'd probably still want mechanisms of controlling the output distribution that just fine tuning wouldn't allow, right? So I think, yes, it would probably work, but either way, you want a mechanism that is more flexible or has more fine-grained control, which I think basically requires that you have like tokenization of the items or something along those lines. It seems a bit unavoidable. I'd have to, if you were really thinking about like fine-tuning this to a conversational corpus that was just so different from anything you'd ever seen on Reddit, where people were having, I don't know, recommendation conversations about their tax returns or something that just doesn't appear in the training data, then yeah, probably fine-tuning would be a very reasonable strategy.
Okay, next question.
Hi, this is James Allen. So Julian, am I right that recall at 5 is the same as success at 5? It just means you found the target document in the top 5?
That sounds right.
So back in when you were showing results and you had the one that showed the language models were head and tails above everything else for the new data set, but that is still less than 8%, which means that if you used this in real life, almost 95% of the time, you wouldn't find the movie that you're looking for. So I wonder, does that mean, and actually the other data sets were only marginally better, does that mean that these problems are just too hard, or that technology, that there's really fundamental core problems that need to be solved in order to get to a level? I mean, in my opinion, I would never use recommendations if it's going to be only 5% accurate or 5% useful. So I wonder what that says about the state of the art right now.
I don't believe it says either of those things. I mean, I think, you know, the recall at 5 is going to depend on the size of the item vocabulary, right? The larger the item vocabulary, the smaller the recall at 5 is going to be, generally speaking, right? And mostly what it says, I mean, you can go use ChatGPT and see how reasonable the recommendations are, but mostly what it says is that there are actually lots of kind of semantically equivalent items. Like, you probably wouldn't expect a restaurant recommender to identify the restaurant you want to go to. That's how data sets are built. We see the restaurant you actually went to, but it's fine as long as the recommender system produces something that is semantically equivalent to the restaurant you actually chose, right? So to the extent that there are many like satisfying restaurants, it doesn't matter. Like to the extent that I recommended a movie that is exactly like what you wanted, it doesn't matter that I didn't get the actual thing you wanted. I mean, maybe recall at 5 is the wrong metric. I should measure like cosine similarity to the item you actually consumed or something, right? But you know, I think that's what's really going on here. It's like the item you actually chose probably still has extremely high compatibility according to a good recommender, even if the one I actually surfaced among the top 5 is not the one you chose, right? And you could think, well, in some settings that might make it useless. In some settings, there really is the thing that I have to find, or it's junk. In other settings, there are many items that are just, yeah, they fulfill your needs. I mean, you shop on Amazon like that a lot, probably, where it's like, oh, I need to buy some underwear or something. It's like, yeah, there's 200 pairs I could buy. They're not going to be any different from each other, right? Whereas other things, it's like, yeah, I better get the exact one. Which is just, you know, it's a kind of waffly way of saying, I don't think you can look at recall at 5 and say it's useful, you know, recall at 5 equals 0.8, therefore it's useful 8% of the time. Like, yeah, I think really going back to my previous point, like the idea of like the withheld item is a bit the wrong paradigm, right? That's probably not how you would use a conversational recommender. Like it's not a search engine. It's not like you know the thing you want and you can't find it. it makes more sense to use these things where you know the characteristics of what you want and you want anything that will satisfy those characteristics. And it's probably good at doing that, even if the recall number is low. That answer was a bit all over the place, but hopefully that came across clearly.
Okay, great. Thank you. Any last minute questions? I think we are almost over time. So if there is not, okay, let's thank the speaker one more time.
Yeah, thank you.
Thanks again. So we are going for the meetings. We have to go upstairs to our office, so probably takes a few minutes. So we'll meet you soon.
Okay, good. I think I'm changing Zoom rooms, but I'll see you there.